Yeah, my friends, China is no longer just showing humanoid robots. What they're doing now is training the world to accept them. First, they had them fighting, dancing, and taking center stage, as if that was something normal. And when the television turned off, it wasn't just that wow factor left behind, but also what really matters. The market reacted, and the purchase of these machines skyrocketed. Now, these humanoid robots are more than just viral videos. They are already gaining natural movement, learning to respond to touch, and even being controlled by brain-computer interfaces where humans control these machines. And in some cases, they are already entering airplane factories where mistakes are not acceptable. Stay with me, because after the intro, I'll show you everything. Everything. Hello, impressed viewers. I'm Carlos Alves, and you're watching Amazing Reality. Let's get to the video. In today's episode, we'll see how China is connecting culture, engineering, embedded AI, and mass production to turn humanoid robots into national infrastructure. Because maybe what's emerging here isn't just another impressive technology, it could be the first humanoid industry on a national scale. There's an event in China that, for the whole country, all these companies and a few others put their machines center stage, performing martial arts, synchronized dances, comedy scenes, and many other things, all in pure live performance. The highlight was clear. The robots ran up a wall on stage as if that was just part of the show. The point isn't just to say, oh, look how cool. It's not only about performance. Companies have already started to show, in quotes, usefulness. The robots are serving food, organizing clothes, interacting with facial expressions, trying to seem like partners. Yeah, not just like machines. In other words, the stage was the spark, but the fire is industrial. And if the gala put the robots at center stage, Jabot decided to go even deeper into that symbolism. Because there's a place in China that really represents discipline, balance, and absolute control of the human body. And that's been happening for over 1,000 years. It's the Shaolin Temple, and that's exactly where Djibouti X2's humanoids came into play. During the event, their robots performed complete kung fu routines with a level of precision that's really insane. And not just visually, it's numerical, response time of 0.01 seconds and accuracy of up to 2 milliseconds in the movements. Yeah, it wasn't just choreography, it was biomechanics, replicated by machine. The X2 robots went through a phase of symbolic training alongside young martial artists, reproducing classic sequences, fast punches, aerial kicks, stance transitions, and techniques inspired by the so-called fire staff. But how does a machine learn something that is so ours, so human? The answer lies in the AI model called Gene Operator 1. It allows the generalization of complex movements from videos and also from motion captures. And all of this without the need to manually reprogram each gesture. Sensors, gyroscopic stabilization, weight transfer analysis, body coordination, the robot uses all of this and the result is fluidity. Actually, it's more than that, it's narrative. Why? Because when a robot performs a martial art that carries centuries of cultural meaning, technology stops being just a tool. It becomes part of the identity. But there's a layer behind this symbolism because the perfect kick isn't the guy's ultimate goal, it's the showcase. While the X2 was showing cultural precision, Agabot was preparing another move, the Expedition A3. If its previous model traveled 106 kilometers autonomously through the streets of China, the A3 was designed for dynamic environments and intense interaction. There are flying kicks, consecutive strikes in the air, a cyclone kick with full vertical recovery. But what matters isn't the spectacle, it's the engineering that supports all of this. A waist with degrees of freedom that are similar to humans. Lightweight exoskeleton, optimized for dynamic stability, dual battery system, with up to 8 hours of autonomy. In addition, it also has quick swap for almost continuous operation. And it's not just about movement. The A3 uses an end-to-end artificial intelligence module. It provides social interaction that they say is more natural, meaning without those activation words. But here's where their strategic point comes in. Unitree and Agabot are competing for global leadership in humanoid shipments. Agabot claims to have already shipped thousands of units by the end of 2025, and they're aiming for mass production as early as 2026. In other words, the stage has now become the commercial battlefield. However, one detail still separates the spectacle from a finished product: the way it walks. And it's precisely this point that has always given away the humanoid robot: the walk. Even the most impressive machines still look too mechanical. And that's exactly what Engine AI decided to eliminate. The SE01 model uses an end-to-end neural network, which abandons stiff movements and starts using gravity and inertia to generate a fluid walk. And it doesn't just take steps. It falls forward and recovers when it needs to. When this technology reaches the T800, the result is an AI and a humanoid that looks comfortable in its own body, with up to 450 Nm of torque in its joints. Aluminum and magnesium alloy structure and processing based on the NVIDIA Jetson Store platform. The T800 combines power with 360-degree environmental perception. It withstands impact, maintains balance, and reaches up to 3 meters per second. But the most strategic detail isn't its speed, it's its naturalness. Because of course, as long as a robot still looks stiff, it still looks like a prototype. When it starts to look organic, that's when it starts to look ready to be among us. And when the body is no longer the problem, the next frontier is no longer movement. It becomes interaction. And that's exactly where this next part of our episode comes in. If the walk has become too natural, the next step now isn't to run faster, it's to respond. To respond to touch. To respond to the environment. To respond to human intention. And that's exactly what Humanoid presented with Tiankung 3.0. Here, we're not just talking about mobility, we're now talking about body control. Dynamic. If you gently push the robot, it recalculates its posture. Touch its arm, it adjusts its strength. Shift its weight, it compensates in real time. All this capability comes from an architecture called Rouge Caillou, which operates in a closed loop of perception, decision, and execution. A small brain controls balance and fine movement, while the large brain manages high-level reasoning. But what really changes the game here is another detail. In a public demonstration, Tiankung 3.0 was filmed turning the pages of a book, using only the human operator's thoughts. And this happened without implants, without surgery, without any drilling into the skull. The brain-computer interface picks up neural signals non-invasively, probably using technology similar to electroencephalogram, and this completely transforms the field. Because when a humanoid robot can be controlled by the mental intention of a human being, it stops being just an autonomous machine. It can become our physical extension. People with motor limitations could, in theory of course, interact with the physical world through a robotic body, and Humanoid goes beyond that. Part of the hardware and software is being released as open source with industrial compatibility via robot operating system, 2 message queuing telemetry transport, and TCP/IP. Yeah, it's clear that it's not just another robot, it's an ecosystem. But there is a definitive test. One thing is to turn the pages of a book, another is to operate where mistakes are not allowed. And that's exactly where this next stage comes in. There is an environment where the margin for error simply doesn't exist, and that's aviation. Every rivet needs to be perfect. Every connection has to withstand decades of flight. Every millimeter matters. And now, in this environment of almost religious precision, Humanoid has started working. Airbus partnered with Aldtech Robotics to deploy the Walker S2, and this will happen directly in their factories, on the production line. In other words, these robots will help assemble Airbus aircraft. Standing 1.76 meters tall and weighing 73 kilograms, the Walker S2 was designed to work side by side with humans. And all this in tasks such as assembly inside the fuselage, quality inspection with advanced sensors, overhead riveting, and inspection in hard-to-reach areas. The most strategic detail is its autonomous battery swapping system. In less than 3 minutes, the robot walks to the station, removes its own battery, installs another one, and keeps working. And this happens without any human intervention. This means continuous operation, 24 hours a day, 7 days a week. Behind this is the Brynet 2.0 architecture, which combines task planning with tool recognition and real-time adaptation. It's clear that this isn't a fixed script, it's operational interpretation. And this isn't just another experimental phase. Hundreds of units have already been delivered to Airbus, and the goal is to reach thousands every year. Now, they're in the semiconductor and aviation sectors, areas where mistakes cost millions. And if a humanoid robot can operate there, it can operate practically anywhere. And at this point, the cultural spectacle becomes too small for the structural change because what started as a performance is now becoming infrastructure. At the beginning of this episode, we saw the robots dancing or, fighting with Gifu in prime time. It looked like a spectacle. Then we saw searches skyrocketing, 300%. Orders were being placed on the markets, then came the 0.01 precision. Second, there was also natural walking and a human controlling a humanoid robot using a non-invasive neural interface. China is not just developing robots, my friends. It is connecting culture, public narrative, supply chain, artificial intelligence, and mass production. It's not an isolated laboratory, whether you like it or not, it's a national strategy. And maybe what we're witnessing now isn't just the evolution of machines, but the birth of the first full-scale humanoid industry, an industry where the mechanical body stops being a curiosity and becomes the workforce. And the question is no longer whether humanoid robots will exist, we're already seeing them out there, right? The question is when they will stop being news and actually become part of our daily lives. When that happens, my friend, you'll see all the details here on Realidade. Impressive. It's a fact that I don't always bring the news firsthand, but I always bring it complete for you and with all the sources, okay? Check the description, and if you're still here, you've already liked. So check your subscription, and if you can, share and hype up this video to help the engagement of your favorite technology channel. Realidade Impresionante, thanks, see you next time. We'll see each other there. Just click on one of the 2 suggestions on your screen. First, share this, hype it up, okay? Thanks, see you, bye-bye.